problem here. Let's look at this one. So we're still doing linear approximation. So it says, on Thanksgiving, a delicious pumpkin pie removed from an oven has a temperature of 175 degrees. The rate of change of the temperature of the pie at time t minutes can be modeled by the differential equation. Remember, differential equation is just a fancy way to say we took the derivative of something. Use the line tangent to P at t equals 0 to approximate the temperature of the pie 4 minutes after being removed from the oven. Okay, so when I first did this one, I made this way harder than I needed to because the letters, the variables that they used were not the variables that my brain really thought like I would have used if I was to write those equations, and so I made it way harder than it needed to be. But let's think about what we need to do. It says use the line tangent to. So if it's telling me to use a tangent line, I need a tangent line, right? In order to write the equation of a line, I need two things. I need the point, and I need a slope. Okay? And so it's telling me to use the line tangent to P when t equals 0. What does t stand for? Time. T is time, not temperature. That's one reason my brain made this way harder than it was. So time. So when time is 0, I need to know what the temperature is. Can I substitute it into here to figure that out? Why is it points? Because it says at time t equals 0. So when the time is 0, that's my x value. Okay? So I have time and temperature here. The time is 0. I need to know what the temperature is when the time is 0. It would be 175. Because when it is removed from the oven, you have a temperature of 175. That's at time equals 0. 175. Okay? So your slope is determined by what? That equation, because that's the derivative, right? So I need dp dt, and remember when it's written like this, we're not doing like f prime of -4 or whatever. It's dp dt evaluated at, and then my ordered pair is 0, 175. Okay, I have to know what is the slope when I have this point, right? So the derivative evaluated at this point right here. I don't have in here, I do not have any t's, right? But I have a capital P. What does the capital P represent? The P is the Y. The P is the temperature of the pie, right? So, because it says the rate of change of the temperature of the pie at blah, 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 blah. So use the line tangent to P, so that's telling you that's the function. So temperature is a function of time, so that P, so this is really T comma P right here. That's what that ordered pair is. Does that make sense? Okay, so then we substitute it in and we get -150 times 175 minus 25. Okay. So that is 150, so -150 over 50 gives me -3. Okay? You see how you have to reason through what the variables are sometimes? Make sure you're substituting in the correct things. Always, anytime we do this, I think every time we have done it, we have found the point and then found the slope. Always find the point first, because sometimes when you find the slope, you only need the x value. It's like f prime of 0 or whatever. But sometimes when you find the slope, you have to actually know the y value as well. So then we write our equation. Y equals, my buttons are all in different places, throw me off. Okay, so y equals the slope, which is -3, times x minus this x value, which is 0. And then what do I do with that 175? Plus 175. Okay. So then I want to approximate the temperature of the pie 4 minutes after being removed. So I can say P of 4, and then this is super important here. Do I put an equal sign? The little squiggly, because it's an approximation, right? It's approximately -3 times 4 plus 175. Negative 3 times 4 is negative 12. So negative 12 plus 175 equals 163 what? Degrees. Degrees Fahrenheit. Okay. What questions you got? We good? Okay. So the variables they can use lots of different things. They can use primes. They can use dp, dt. That, you've got to make sure that you can make sense of all of that put together. Okay. Are we good? Any questions? All right. So I want you to work on that assignment then. Practice through that.